At the back, is mic working? Yes. Okay. Good evening, everyone. Thanks for coming and joining in the middle of the week. Really appreciate all of you showing up today. And thanks for ClickHouse and PeerDB team for inviting. We are really happy customer of ClickHouse, and today I'm going to tell you a story about how we started using ClickHouse and what do we do with it. Hope you find something useful today, and hopefully some of the learnings you might be able to implement in your systems. You can ask me questions in middle of the presentation. It's a very short one, like 7 slides, and I'll be here for dinner as well. So if you guys want to catch up, please do. So we are Gumlet. Those basically what we do is like we have an image and video infrastructure. So we provide basically like image and video storage, streaming, transcoding, analytics, and CDN. So the entire pipeline of image and video delivery is taken care by Gumlet. We have like India's largest news and media companies, e-commerce companies, social media companies. A lot of them are powered by Gumlet. And we do like around 2.2 billion deliveries of image and videos every single day. So that is the scale. We touched around 100 million users across our customers every single day. So that's how big the scale is at which we operate. So as you can imagine, like we store data for all of this. So we are talking about like around like 900 billion rows of data. So that's what we store, and that's just for one image delivery. I'll explain it later about how it's not 900 billion, how it goes even further than image. That's minimal that is there. Anyway, analytics is like super crucial for video, and we do it for images, but I'll do even more dig into the videos. Why it is because there are like usual suspects, like where you have to analyze like internet traffic or web page traffic. You can use like Google Analytics, Mixpanel, and ton of other things. But video is very tricky. What happens is like video data is a temporal. It's not like one in time. You cannot analyze like a page view from where the referral came, how many users viewed this page. It's impossible. Why? Because the data basically flows over time. So people just start viewing the video, then they go on the entire video, then they pause it, then they start it again, and then they skip some part of videos, and the capturing the entire information across like millions of videos is extremely tricky. And that's the reason we have built our own entire analytics, apart from obviously the other things that we do. I'll not touch base upon the transcoding, storage, the CDN, and all other parts. I'll just focus on analytics today. So that's what we built. And you can see like these are the metrics, but I'll zoom more into it. So we track things like unique users, playback time, latency metrics, rebuffer metrics, bandwidth statistics, all these kind of different things. So for example, you can get an answer about which city in India had a more than 2% rebuffer rate on a given day. This kind of answers can be found out with using Gumlet dashboard within like seconds. And that's what we provide to our customers. It also helps us improve our infrastructure. So what we do is like we take all the statistics that we collect while the videos are being streamed, and we improve our service. That's the reason if you try Gumlet, it's like one of the fastest video service, along with let's say YouTube, right? So YouTube obviously has like extremely good, but we are like equally fast service out there. And on image side, basically like when you see any news and media website, there are like all the images load. So we have like things like image bandwidth consumption, request, which is like very basic. But then like hit ratios, error statistics, top images and top assets and sort of those things, popular assets, and different statistics about how the images are being performed. So for example, we give our customer stats about like how much time do the image transformation take, because we let's say convert 1,000 pixel image into 500 pixel image. We convert the formats, and a lot of time customers have the apprehension that hey, this processing on image, which is being done on real time on image and video both, by the way, it will consume a ton of time, but which is not reality. We just do it in almost less than 100 milliseconds. So those are the statistics that we track, and that's the reason we need something to analyze it. So what we got started with was BigQuery. We used around like in 21 we used BigQuery for all of the purpose. The architecture was like we like to keep extremely simple, and I'll give you some lights on our architecture, and you can ask us more. But at that time, the architecture was so simple that what we did is our CDN provider called Fastly. They had something called BigQuery connector. So what we'll do is like Fastly will directly send the data to BigQuery, and that's it. We fetch the data from BigQuery and we analyze it. Sounds really simple. It is how it was. We never had any ingestion. We never had anything else. It was all BigQuery and Fastly. However, there are obviously the problems. BigQuery has an ingestion cost when you do insert data the way we were inserting, which is the real-time syncing of the data. And there is obviously the analytics cost. Like every query costs us money on BigQuery. Whether it's a ton of money or a small amount of money, depends on what queries you fire. But if those who are interested, like who have worked with BigQuery would know that it incurs the cost. On-demand version of BigQueries are limited to like 100 concurrent queries at any given time. So if our customers had to like fire analytics APIs, which we provide to our customers, more than this, it would fail, or it has basically goes to a queue. Okay, yeah, it's possible. Okay. So that 100 concurrent queries was the on-demand. Yeah, we could buy like a dedicated BigQuery, but it has other problems anyway. And then the storage was logical. Now it is changed in recent pricing update, but in past the storage of BigQuery was logical, which means like let's say if you stored in 32 in BigQuery, they would charge you for 32 bytes, which was crazy. Because many of our columns were basically like just status code, which means like 200, 200, 200, which we are writing, and we are paying like 32 bytes for all of every single data point, which is like a billion of the, like 500 billion of them. You can imagine the cost. So we already had to find something we wanted to change. There are usual suspects: Athena, Redshift, ClickHouse, Snowflake. Yeah? This is what we evaluated. But what was our criteria? The criteria was basically scalable storage. We wanted to start with like tens of terabytes of storage. Yeah.
Have you got any comparison chart for this data, like what you find in an Athena, Redshift, or Snowflake?
I will cover. I don't have chart right now, but I'll cover verbally. If you want, we can send you something. But yeah, okay. I'll just cover it right away. That's why I put it. These are the parameters and what failed at what parameters. So we wanted like scalable storage, which is tens of terabytes of data to start with, and it should be able to grow. No price per query. We didn't want to pay per price per query because our customers do use a ton of analytics through APIs, and it can become like extremely crazy if I have to design our pricing model according to this. We wanted like great documentation. Even like you might be surprised that BigQuery didn't have as good documentation as it should have. Many a times we are just stuck on Stack Overflow, which is not a great thing. And no maintenance. We didn't want to maintain. We are like extremely lean team. We are like around 12 engineers working out from remote in entire India. We don't have like a SRE. We don't have DevOps team. We have now nobody. So we wanted like something that would just fly. We don't want to manage it at all. Now Athena has checks first box really well. You can store terabytes of data on S3, and Athena will happily query the data. Where it fails is there is a price per query, and second, the queries are extremely slow. So Athena is not built for speed. So if you are sifting through like let's say 10 terabyte of data, it will take like 15-20 minutes, not even like seconds. Okay, so strict no for us. We just tried it quickly, just rejected it. Redshift has a little costlier storage and very costly computation. Still no price per query, and documentation is fine. It's good, but it doesn't come into comparison of what the next two are, right? Now let's come to Snowflake. It has scalable storage and no price per query, exceptional documentation. But Snowflake is extremely costly, like especially at the data size that we had, it became really costly. Performance-wise, we did test a little bit, frankly, but we didn't go too much deep into it. We never put like a terabytes of data into it because just out of the pricing perspective, we couldn't go for it. So in the end, the option was left, which was ClickHouse. So we evaluated open source, and in the end, we decided to move to ClickHouse Cloud. It was like totally self-serve. We started, I think we were one of the very early customers when ClickHouse Cloud launched around 1.5, 1.7 years ago. And at that time, the dashboard looked like completely different in the ClickHouse. But we are happy. All we could do is just fire some SQL queries, see the tables, and generate username and password, and we were happy. So that's what we did. We just got ahead with it and never looked back. Okay, so I explained what was stack before ClickHouse, right? There was this Fastly, then the Fastly would come to, Fastly would push data to BigQuery and period, right? After ClickHouse, we had to change like ingestion process. This is where, you know, if you are onboarding on ClickHouse, you should be aware about what is going to happen. This is all I will cover, and like and then the features, and then some caveats. Any questions so far? Should I stop or should I go on?
Is that the managed ClickHouse or?
Yeah, this is managed ClickHouse. So for our experience, only the ClickHouse Cloud. We never managed our own open source deployment of ClickHouse. So yeah, that's managed ClickHouse. On the database side, we are 100% MongoDB shop. So I don't know anything about Postgres. I don't know anything about MySQL. We have been running, like I personally have been working on MongoDB since like 12 years, and the primary DB is MongoDB, and the second, the analytics DB is ClickHouse. That's how we have been always. So yeah, this is ClickHouse Cloud.
So a couple of things. You directly connect to S3 via the ClickHouse feature that it has, or is there anything special that you do there?
Yeah, we directly do that. I'll explain that. Yeah.
That's there, right?
Yeah.
Connection probably is there.
Yeah.
And what's the scale of storage that you're using for these videos, images? Because ClickHouse natively does compress to 10x. You know, what's the ratio for images and videos that you are experiencing? What's the kind of compression?
Okay, we are not storing by the image and videos.
You don't.
Not the image and videos. Not inside ClickHouse. We don't need, like, image and video shouldn't be stored as per me inside any database. So the storage is obviously some persistent storage like S3. This is only analytics data that we have. What are the events, different events, requests, network requests, play, pause events, all those stuff. Those are the things which are there in the ClickHouse. And that data we are like, yeah, ClickHouse comprises like very well around like for our data sets, it is around like around 9x or 10x compression. And with that, I think we are consuming around like 20-25 terabyte of data in ClickHouse. So actual data would be like 250 terabyte plus sort of a data. That's the raw data which we would have. Okay, so what we do is like we have analytics libraries. So like if you are using Android, web, iOS, whatever you are using, basically our analytics library captures the data about video playback. So like somebody starts a playback, there is a play event fired. Then when the player initializes, there is initialization event fired. Then there is pause, and there are like skips, and then buffers, and all those events are different events which are fired, and they're collected by the analytics SDKs and sent to something which we call our Golang service. So it's a Golang module, basically like gets all the data in, processes the data, batches the data, and then sends it to ClickHouse. This is this deviation from our previous Fastly, because we did move away from Fastly as a CDN, so we had to like develop something our own, and that's our solution. So Golang basically like works as like aggregation of everything. Just takes data from everywhere, processes it, and then pushes to the ClickHouse in the batches. Here, one of the interesting part about ClickHouse is that it's always great to push data in a as large batch as possible. So if you understand, like if you go and check the ClickHouse internals, They use something called merge trees. What it means is basically like it merges like a batch of data, processes it, and then writes it onto disk. So if you write like too small of a chunks, like for example writing 10 rows at a time, is extremely less efficient for insert as well as query. ClickHouse does a great job of still making your queries really fast, but the recommendation don't do it. So our basically default size is around 20,000 rows. We found out empirically right now, we it configurable, but 20,000 rows is a batch which we just insert once. That's around like, that gives us an insertion frequency of around like one batch in 10 seconds, so which is good enough for us. So that's what is done in the real-time ingestion. We have a ton of logs in S3 as well. So for example, our CDN sends a log, some of our different services sends a lot of logs to S3 in a JSON new line format as well as the CSV format. And we have to import that to ClickHouse to analyze it further. We use like very simple ClickHouse S3 import functionality for that. So ClickHouse is a really nice like S3. You pass some credentials, pass the table, like the path on S3, and that's it. And it will import all the files. There also there is a caveat. For example, we end up with more than like I think 5,000 files in an hour, and we insert this hourly. The problem is that inserting 5,000 files in one go, many times this ClickHouse throws error that the whatever, like some buffers are full and all that. And we talked with the ClickHouse team. The best way is to like insert like small number of files in one go. So we add like 50 files at a time, and works beautifully well. That's it. That's our ingestion pipeline. So how we get the data into ClickHouse. Okay. So and then for analytics, basically what we do is like whatever once the data goes into ClickHouse, everything is real time. So now our dashboards, if you go to our dashboard, click on any sort of analytics, we fire query to ClickHouse and then get the results in real time. There are obviously some materialized views we have made to make this much faster, but that's it. Apart from that, we don't maintain much of the things. We just define like what is required for a stat. For example, let's say you want to know the views of a certain video at a given point of time. You just fire like this is the video ID, what are the number of views, and then the time frame and all the stuff, and we get the data. There is no caching layer, nothing else. It's just ClickHouse, materialized view, and then our application, which is firing the data call. Really simple architecture, no other complexities out there. So if you are thinking about whether you want to cache this data, do that. We don't do that, and it still works like beautifully well because ClickHouse supports like a concurrent queries, which are that way we can run like even like 500 queries in one go, and still it gives the data really quickly in like within 2-3 seconds, not like in minutes.
So using ClickHouse, you can query S3 directly, right? We can, but that is very slow. So when we query S3 using ClickHouse, like for example, we can do like something like select star from S3, some blah blah blah, right? Because S3 speeds are very low, it becomes like extremely slow because those files are in CSV format. They are not in the columnar format that ClickHouse actually uses. So for example, if I have to query data by certain time frame and certain attributes, let's say for example for our use case, let's say I'll take the same example that a certain video ID I need to find out. It's impossible for S3 to know where this file ID is in which CSV file, because there will be like millions of CSV file in the end if we do that. If we query that video ID, it has to go through every single row of the CSV and find it. It will find it eventually, but I think yeah, shouldn't do it. We use something called like a primary key feature of ClickHouse, where we the very frequently queried data is on the primary key. So basically, we make it much faster than it is.
With the amount of data what you are having, it's like huge numbers. So may I know like how are you replicating or sharding the data so that you can query these parameters like faster?
We don't. Yeah. So we use ClickHouse, which basically has like I think puts a three member replica set. If I'm not wrong. Yeah. by default. So yeah, three replica set which they put. I didn't even put it, right? And yeah, that's it. That's all we do. We don't do anything else apart from this. Yeah. Yeah, so there is a raw data, then there are MV materialized views in front of them, and I think yeah, that's it. That's all we do. Yep. Okay, so CSV files are generated by 2-3 things. One is some of our internal services do generate CSV files and uploads to S3, which is basically image processing data about like how much time did it take for images to process, what happened, what are the formats, what is output size, what is input size, ton of things. So image processing data, which is like around like I think 20, 25, 20, 22 columns of data, which is generated in an extremely high volume. I'm talking about like hundreds of millions in a day. So that is that data. Second is our CDNs put all the logs in either JSON or CSV formats, depending on the CDNs. We use CloudFront and Cloudflare, and they put the data in a CSV or JSON-L formats back to S3. And those volumes are, as I told you, in a billions. So they are also put in S3, and hourly we using a cron, which is ingested to ClickHouse. So the CDNs put data very continuously, like it puts like data every other minute or every half minute, but we don't need the data to be in ClickHouse that fast. So what we do is like every hour we run a cron, which takes like around like a 1 minute time to ingest like some 100, 200 million rows, and like that's what it is.
I was also very curious, why CSV, why not something else?
That's because CDN support that only. Like for example, CloudFront will not give you a CDN log in anything apart from CSV. So I mean, I don't have a choice there. That's as simple as that.
How do you handle your schema evolution?
Sorry?
How do you handle the schema evolution of your events? Your events you are putting in, posing nobody, right? You don't want to stick your schema of those events. Correct. How do you handle if that evolves and you ingest into ClickHouse? Are you restricting your events for schemas?
Yeah, we have schema for events, but we don't put it in MongoDB. By the way, MongoDB, I just mentioned that.
This question is like schema registry. If you see the Kafka, it is there. You can use protocol work. It can be backward and forward compatibility. This question is that for handling this in the event, message is going. Tomorrow, in place of mobile, email they put. In place of a pager they put. Or if event is keep on changing with the attribute. For handling that, what schema registry or what are the details you are
We don't, like, okay, so I know there are a ton of industry standards. We don't. We just as I told you, our Golang basically makes sure that all the input that comes adheres to what schema we need, and it's very manual. That's how we are. Like we are not like always sticking to the schema of industry. Yeah.
So you are not like restricting. You are restricting to not have nested JSON or nested arrays of objects, right?
Right now in our database, in our production system, there is no nested. We all have like just columns and columns of data. Yeah, single level data. Only columns are added whenever we need it. But now in 1.5 years, we have like changed the schema of DB schema. If you ask me, we changed the DB schema like a few times by adding columns. But that's it. I mean, we didn't have to do anything else apart from adding a few more columns which we thought we needed. And we don't utilize the JSON and nested and all the stuff. I think it was not there in ClickHouse, if I'm not wrong. And we just worked around that. And that's why the Golang ingestion basically has all the validations, type checkings, everything is there in the Golang, which makes sure that the data that goes to ClickHouse is not garbage data.
So can you please share some insights whenever you are adding or removing the extra columns? For example, if you are having 25 TB of data now, and now after adding 5 more columns, so we might like again ingest like X number of data, X terabytes of data. Then what are the insights like that?
How do you migrate that over?
Okay, so I think this question coming because you are coming from Postgres and MySQL world, right?
We are using ClickHouse.
Okay.
Think that like now we are having a table in ClickHouse,
Huh.
and then like we have done all the materialized views. So now there are extra columns that you have added now. For example, 5 columns were there.
Okay.
Now we have added any additional 5 columns because we wanted to capture some more events on.
Correct.
So how we are capturing
It doesn't have those 5 columns. It has null values in the end. Yeah.
Null value. And we don't index these things for any way or oh, you are using materialized view so that like you don't have to do anything.
Yeah. So we change the materialized view, but we account for the null data which is there. So yeah, I mean we don't care. And I don't know if you are asking about like whether the adding column is very easy in ClickHouse. Like unlike Postgres and all, which takes like hours to alter table. Here it will like happen in like a second. So and yeah, the MV basically takes care of the null values, and then yeah, then life goes on. We fortunately didn't have to do it a lot. We designed the schema really well, and we carried forward our schema from BigQuery. So because basically BigQuery is where we did all the experimentation. So when we came to ClickHouse, we didn't have to fortunately experiment a lot. But we did add columns, and it turned out to be okay.
My one question is like you say that you store like audio and video. I was working in one of the company. They store into a network file system because accessing it will be faster. Then why you are storing this video file into the S3? Like your network file system will be much faster than the S3.
Oh, because we have to stream them. So, for example, like when we process, let's say one of our customer brings a video, we create like multiple resolutions for the adaptive streaming and all this stuff, and we create like multiple videos and audios. We have to store to S3 so that people can stream it after some time. Like for example, using a CDN. If we put in an NFS and all, it will be like really painful to stream them and all this stuff. Plus, like S3 is way cheaper than any NFS will ever get cheap. So yeah. Okay.
S3 like is the when they store data, is they compress the data or they just
No, S3 doesn't compress. S3 will keep the data as it is. They won't compress anything. Okay. So as I told you, like there is ingestion, then there is the pipeline where we get the data out, which is very simple. As I told you, materialized view and our APIs. What are the impact, right? Fixed cost. This is what we were after, and that's what we achieved with ClickHouse. Our cost on month is now like really fixed. Only storage cost is variable, which is like whatever incremental storage we add is charged extra. But for compute, we know what we are going to get charged, and which is very important because that's the costly part. Storage is not that costly. Even 25 terabyte of storage is not that costly. It's the compute which per query and all is extremely costly. Ingestion speed from S3. So previously we had like whenever we had to do this CDN logs ingestion to BigQuery. I didn't cover that part, but we had to do something using our crons. And because each and every of those crons handle like 2 to 300 million rows every hour, we had to do multiple rewrites of those crons. So we went from like a normal Node.js, which we do at the time, to Golang, to Rust, to make sure the data gets ingested. But even then it was like super slow. So when we moved to ClickHouse, we just threw all of those stuff. And ClickHouse takes care of it in less than 2 minutes. And fast response times, obviously, fastest database in the world. So can't argue with that. All of our data, as I told you, the dashboards are powered by ClickHouse. So all of our API response times, everything is dependent on ClickHouse performance. But yeah, it's holding up. So super happy on that front. And there are a few changes. This is my last slide. There are a few caveats when you are migrating to ClickHouse. We suffered, but we are listing out here, so you don't. We had to change our BI tool. So basically, we used something called Google Data Studio because we are using BigQuery, so they work really well together. But ClickHouse doesn't have a Data Studio connector. So what we had to do is we had to change our BI tool. So now we are all in onto something called Metabase, which gives like a BI for everything, like MongoDB and BigQuery and every single thing. So we had to go through the change. It's a big change because we had like multiple tables and multiple analytics dashboards and ton of things which were made. So that was when we had to export data as a Parquet files, if you are aware about that format, and then import into ClickHouse when we migrated to BigQuery to ClickHouse. We could use some ETL tool, but this is the way we chose. something will come up. Just be mindful if you're changing it. We also had to change ETL tool, by the way. Not all ETL tools still support ClickHouse Cloud or ClickHouse Open Source, so do check before your ETL tool actually supports it.
So why don't you save directly the data, whatever the analytics data you make, directly in the as a paraquet file in the S3? It is I think it's already compressed version.
Yeah, but for Paraquet, if I give Paraquet file to ClickHouse, it's way slower than what I give to ClickHouse native with the merge tree, replicated merge tree is way faster.
Paraquet file is much faster than CSV, reading the CSV.
See, I don't have control over CSV. Think about it, like the CloudFront is only giving me logs in CSV. Now I have a choice, either I ingest CSV directly to ClickHouse or I convert it to Paraquet and then insert it to ClickHouse. So what we choose is the CSV to directly ClickHouse. We don't want to.
For the later use, let's say if you want to use later the file, then you can directly use the paraquet file. That will be much faster. So for the like.
But that's why I use ClickHouse, no? It's like this single source of truth, like.
More faster,
See, ClickHouse is way faster. So a single source of truth, no data replications. One place there's a state data.
We have been doing some data analytics. So let's say we want to do some. So we are using Python like pandas library, and then while doing, let's say we are doing 1 million row processing, it takes 10-15 minutes in the CSV file. But if we are doing some
Paraquet.
like feather file format or paraquet, then it happens in within 2-3 minutes.
Yeah, that's the problem. See, point is, Paraquet file has a problem. I had like extremely deep experience with Paraquet file in past. Paraquet files are not as fast as when you go to a billion row realm. When you are in millions row realm, it's good. It works fine. When you're going to a billion rows, 5 billion rows, 10 billion rows, that's when the problems start emerging big time. And as I told, like we deal with like 2 billion rows every single day. So that's where Paraquet files like need an extremely large amount of memories, and they are like Python and Paraquet combination is extremely slow in my experience. Maybe I'm wrong, but I think I worked in Python and Paraquet for a very long period of my life. So ClickHouse is just hands down beats it.
So you're storing data in ClickHouse native format then?
Just ClickHouse, just give it to ClickHouse. Yeah, something called replicated merge tree is there in ClickHouse.
And after that, are you kind of exporting that?
No, we don't.
ClickHouse native?
No, we don't.
Like that. That's even faster. So
What is ClickHouse native?
So all that data from that table, we put it into ClickHouse native. If tomorrow everything fails, I just take that data, it gets automatically loaded to ClickHouse.
Yeah, that is what for the backups are there. I think ClickHouse Cloud provides backups, so I think, yeah, true. Okay, last 2-3 points. Datetime 64 is not that performant. Maybe I'm wrong. I'll take this with a grain of salt. I'm not 100% sure, but we tried this. There is some column type called datetime 64. It's very slow in ClickHouse. In our experience, especially in a billion row order. Be careful if you're using it. Do your benchmarks. We ended up using only datetime, not datetime 64. Schema changes for sampling. There came a time when we wanted to do some sampling on our data sets, and it requires something called changing a primary key, and primary key is not allowed to be changed on ClickHouse without completely dropping and recreating the table. Be very careful if you have to do sampling. Define your schema while you create the table, not after inserting the data. And yeah, last is this is something which some of our engineers recently found out, that our data size was growing like little faster than we expected, and utilize something called low cardinality and delta compression in ClickHouse. So what basically does is like we have some columns which is called status, and almost all states are 200, and then there are some 404s and things like that, right? No need to store them as a int 64, which we used to store it as. Just use something called low cardinality, and it will like compress data way better than anything else, and the queries are also way faster. Same for delta compression if you have like numeric data. And these are some caveats. Do take care when you are moving to ClickHouse. My experience is really tainted by the cloud, so I might not be able to answer your questions about how to manage and host those things, but But yeah, for ClickHouse as a product, this is what our experience has been, and yeah, that's what we do. In case you want to ping us for any video or image needs or anything you ever have, just ping us on Twitter. We also have something called community.gumlet.com where you can come and ask questions about video and images. That community is open, free to join, and like our engineers do reply to your image and video questions. That's what we are expert in. So that's it. But I'll take questions. This, I think, how much time we have?
Like a couple of questions.
Okay.
So you mentioned you moved from datetime 64 to datetime, right? Since you're doing events, doesn't that last milliseconds matter?
It does, and it's painful.
So it's a trade-off.
Yeah, so what we ended up doing is we ended up saving like millisecond as a different column, which is way faster. Sounds crazy, but yeah, pain.
What's the data type of that millisecond?
That's this is an int column. Yeah.
Sorry?
That's an integer in 32 column. Yeah.
Can you please tell me how many days the data is retained and then like what all data is input to cold storage?
We don't put in cold storage. So our like whatever terabytes of data is there, since we moved, yeah, I mean, what 3 plus years of data. To our customers, the video analytics, we provide like a 7 plus years of data. But that's what we write. But I don't think we'll ever delete this data.
Sir, how did you reach the conclusion that datetime 64 is not that performant?
I don't know. That's what we found out when we built the tables. We built tables and then we started querying them, and then it was way slower. I don't know. That's why take it with a grain of salt. I don't know, but something went wrong there, and we saw that not on ClickHouse documentation, but on the Stack Overflow or somewhere. I don't know what forum. Somebody told that the culprit was datetime 64. Just convert to datetime, and you will be flying like crazy. And we did it, and like immediately that got solved. So yeah, I'm not expert in internals of ClickHouse, but something is up there.
Did you guys talk to ClickHouse Cloud guys?
We did, and they are like, why don't you use datetime? If possible, why don't you use datetime? I'm like, yeah, fine. It's painful one, yeah. Good feedback for you guys, but yeah.